Hello there and welcome back. Yes, surprisingly enough, I'm here with the next episode of teaching my computer how to play Snake. Sorry it didn't come out on time, but I think you guys will find it was well worth the wait. A lot has changed between now and the last video, and actually it has been quite an enjoyable experience this time, believe it or not. Yes, that there in the background is a working version of my network. I'll leave that there for y'all to watch. So as you may remember, last time I left off rather disappointed, but I was still hopeful, and that hope paid off. While the updates to the Deep Learning 4J library did not fix my random crashes, which have now been reported as a bug, they have greatly simplified and cleared up how to use RL4J. I only really ran into one big issue, and I was even able to solve that. Importantly though, I managed to figure out some settings that didn't lead to those crashes. Not exactly sure what I did. This has allowed me to focus on actually teaching my network and tuning my network, and less on struggling to understand the library that I'm using. I think that's been a really big thing too, the fact that I finally started to understand RL4J and how to use it. Now really quickly before we get to the main part, I want to talk about the most noticeable change to my network, the UI. I promise it will be fast, but I spent a lot of time on it, so I at least want to mention it a little bit. Previously I was using a library called Swing to create the UI. Swing was the original graphics library for Java, however it hasn't aged well, so I transitioned to JavaFX, the new and improved graphics library. Swing is great in the fact that it allows for rapid prototyping and is easy to learn. JavaFX isn't really made for that. It's a lot slower to create programs with, and it's not very easy to learn. But when you want to make your design look really good and focus on aesthetics, it's really the only option. I was pretty tired of tuning my network one day, so that's exactly what I did. I know it doesn't look great, I'm not a graphics designer, but now the little boxes of Snake aren't scattered across my desktop, and the graph doesn't look absolutely atrocious. Alright, that's it, back to the focus of the video. So the question of the day, what has allowed me to get my network to start learning? Well, as the saying goes, less is more. If you remember, the way I was previously feeding my information to the network was, I would send the entire game board, basically as much data as I could, and then see how good it could get. I was basically just hoping that it would learn. That was a mistake. I even started to realize it, but I didn't feel like taking the time to actually fix it. However, I finally broke down and did. It wasn't that hard, it only took like 20 minutes. The first thing I tried was giving my network 6 inputs. I would tell it its direction of movement, the angle between the apple and the head, and what was immediately above it, to the left, and to the right of the head. And to my surprise, my Snake instantly started learning, averaging about 7 to 8 apples each run, with one of the highest values I saw being around 25. It was leaps and bounds above my original design, which averaged an apple only every few runs, and which probably never even reached 8 or 9 apples in all of my testing. But you may be wondering, why would using so many fewer inputs result in drastically improved performance? Well, to find that answer, you must think about how machine learning works. Basically, the computer has to learn how the inputs it receives and the actions it takes based on those inputs affect the rewards it receives. So, the network must simultaneously learn 3 things: what the inputs mean, how the actions it takes can affect the environment, and what environment states and corresponding actions result in positive rewards. That is no simple feat, and the more inputs the network gets and actions it can take, the more difficult it is to learn. So by giving the network 256 inputs, originally it was extremely difficult for the network to learn anything. Think about it, when you play Snake, would you care about an empty space 20 moves away? No. So by reducing the inputs to what's necessary, the network is allowed to not just quickly learn, but also more efficiently optimize its decision making, increasing the amount of rewards it receives. But you can also give the network too few inputs, and while I was giving my network enough to learn, it could never learn an optimal strategy. The minimum inputs required for the network to learn optimal behavior is 2 spaces vision. Then it could see a wall before reaching it, allowing it to learn the most basic way to beat Snake, by following the exact same path over and over again, which is only possible if you turn before reaching a wall. So that's exactly what I did. I gave my Snake a 2-block vision field, along with a diagonal vision. However, it didn't learn the optimal strategy, but I didn't expect it to. That is a strategy that would be very rare for a network to learn, naturally, but my network did see improvement. Its average was around 14 to 16 apples, and the max that I saw it was at in one life was over 40 apples. However, there is diminishing returns. More inputs will get you less performance along with longer training times. I could possibly get the network to work with all the inputs, but the time and effort just isn't worth it for what this project is, which is just a learning experience. I think it's also important for me to mention some other changes I have made to improve my program and make training it a lot easier. The biggest would be that I improved performance. I moved all the unnecessary calculations and rendering off the learning threads, leaving them just to learn. For instance, I handle graphics rendering on a separate thread so it doesn't slow down the network, along with my computations to produce the best fit line. Additionally, I reduced thread blocking. There's a spot in my program where all threads have to report their scores so I can show the graph. However, only one thread can report a score at a time, and its score must be logged and counted before another thread can report its score. I tried to reduce the time that any thread was holding onto that lock to increase my performance yet again. While these changes might not lead to any noticeable difference, when watching a network over the course of a 2 to 3 hour training, the increase in speed does become apparent. So at this point my program is basically finished. I have polished it to the best of my ability, but it does still suffer from a few problems. The crash that terminates the entire program, memory overflows that I have mostly been able to stamp out, and a greatly reduced but still noticeable degree of variation from run to run. Truthfully though, these issues are rather minor, and I'm happy with what I've accomplished and learned. So what next? There's so many options for what I could build or create, especially now that I know how to train a reinforcement network. An idea I had is I could train my network using images from the Snake game instead of just a clear input, but that really doesn't sound fun to me and I'd rather just move on. I might try it, but I won't make a video out of it. I did have another idea though. I could finally getting around to trying to hook up my Kinect to my computer, and train it to recognize my face versus a dog or something else. That would definitely get me closer to creating my facial recognition lock, and it would give me a chance to use this library that I just learned. But that jump is still a little too big. I've tried to use a Kinect to my computer before, and it's not easy, especially when I want to use Java. Additionally, I'd probably have to create a different type of neural network, as reinforcement learning doesn't seem to be the best option for facial recognition. So I think I'm just going to start smaller. I'm going to try to make my Kinect into some sort of controllable camera. I'm going to use Java and create an interface where you can control the camera, its settings, like its resolution, color versus night vision, among other things. Maybe I will even make a little local server to access it from Wi-Fi. Definitely not anything connected to the open internet though. That is assuming I can figure out how to use the very poorly developed Java Connect SDK. So that's what I'm going to be doing for the next few weeks. Hopefully I can get a video out on it in a reasonable amount of time, and hopefully it'll be interesting. I'll try my best to get it done, I promise. And that's it. I taught my computer how to play Snake using reinforcement learning. Thank you for watching, and if you enjoyed, maybe leave a like. Also, if you're interested in the code and maybe trying to modify it, I'll leave a link in the description. It's not super well documented, but I'll try to fix that in the coming weeks. If you have any questions or future ideas for a project, just leave them in the comments. Have a great day.